Hello, Ramakant. Are you able to see my screen?
Yes, ma'am. I'm able to.
Okay. So just let's wait for just 3-4 minutes for others to join, then we'll start.
Okay, ma'am.
It's 6:10, so we can start the lecture now. Both of you are able to see my screen and hear me.
Yes, ma'am.
Okay. Gabriel, you? Thanks. So I'm your NPTEL TA for this aluminum alloys and mathematics composite course. So I will first start with the. Have you gone through the lectures of Professor Ranjit Pauri?
Not all of them, ma'am, but somewhat.
Okay, means week one lectures, some one or two you have done.
Yes, yes, ma'am.
Okay, okay, then we'll start introduction. So the aluminum alloys are generally known uh, of their lightweight, of their lightweight, and it's a high specific to means a high specific strength to weight ratio. So its density is around 2.7 gram per centimeter cube. So this is just 3 times lower than steel or iron, and its melting point is around 659 degrees Celsius, and boiling point is 2270 degrees Celsius. Its thermal conductivity is around 237 watt per meter Kelvin. So, and the thermal expansion coefficient is 23.5 into 10 raised to power minus 6 uh, per Kelvin. So this thermal expansion coefficient is at the temperature of 60 to 100 degrees Celsius, and its electrical resistivity is at room temperature is uh, 2.65 into 10 raised to power minus 6 ohm centimeter. So as its electrical resistivity is very low, when its conductivity is very high, and its thermal conductivity is also high. So it is a very good conductor of heat and electricity. Then its crystal structure is FCC. Its latest parameter is A is 4.05 angstrom, and its atomic number is 13, and atomic weight is 26.98, approximately 27, and it is a paramagnetic material. So these are the general properties of the aluminium. So, and its corrosion resistance is also high. So means it does not rust, make a rust. Means in iron or steel we can see the rust forming, and for copper and silver also we can see the some rust form on because of the oxidation. But aluminium alloy have very thin layer of aluminium oxide around 5 nanometers. So it is very thin and very adherent to the aluminium surface. So it will prevent the further corrosion of the aluminium. And if we talk about the its purity and mechanical properties, so generally purity is around greater than 99.99%. So if we decrease the purity, its mechanical properties we have like yield strength, yield and tensile strength, and ductility. So the highly pure aluminium is very ductile. We can form any shape from the high purity aluminium. And if we decrease the purity, means mix any other alloying element, so we increase the strength and decrease the ductility. So if with decreasing purity, its strength goes up and ductility goes uh, down. And its elastic modulus is around uh, 72 GPa, and its shear modulus is around 27 GPa, and its Poisson's ratio is 0.34. And so these are the general physical and mechanical properties of the aluminium. And next is the what are the impurities in aluminium can be there. So first we will talk about the sources, means where the impurities come in the aluminium alloy. Impurity sources. So the main sources are the uh, during the extraction process. Next is the makeup chemicals, means in refining we use various type of chemicals. So from these chemicals, the impurities can enter in the aluminium melt. Next is the anode carbon. So this is in the refining process. Anode carbon, refractory lining, and fifth are the steel tooling. So these are the sources of impurity in aluminium. And what type of impurities come under these categories? So first is the elemental impurity, elemental like iron, tin, zinc, copper, magnesium, and etc. And also inclusions, means the compound. So inclusion forms during the extraction or refining processes like oxides, carbides, nitrides, and boroids. So these are the impurities in the aluminium. So, and next is the hydrogen gas is also present as impurity in the aluminum alloy, as the aluminum is very has very high affinity uh, for the hydrogen during the liquid state, and as the aluminum solidify, the solubility also decreases. So, but during the solidification, if hydrogen gas could not escape from the melt, so it will lead to porosity in the aluminum products. So this is very detrimental, means the porosity will reduce its mechanical property. So what are the effect of these impurities? So the elemental impurities like iron and silicon, uh, it have effect on the tensile properties and surface finish. Means tensile properties, we just now see the strength and ductility. So tensile properties and surface finish. And some other elements like titanium, chromium, they increases the resistivity. Means the highly pure aluminium has very high conductivity, and if we increase add some elements, so they decrease the conductivity and increase the resistivity of the aluminium. Titanium, chromium, manganese, and vanadium. Next is the sodium. So sodium causes embrittlement. Embrittlement means the decrease in ductility, means the material cannot sustain the much deformation. So the sodium causes embrittlement, and silicon, if it is present, so it lead to edge cracking during hot rolling. So what are the applications of aluminium in, in the industry? So first application, it comes in the electrical conductor because it has very good electrical conductivity. Electrical conductors. Second, it is in the packaging industry. Third is the chemical industries, and fourth is the household or architecture. So now we'll talk about the extraction process of aluminium. So the mineral or ore from which the aluminium is extracted is the bauxite. So the formula for means bauxite also contain two types of mineral. This is ore and this is the mineral in present in the ore. So gibbsite, which have formula of Al2O3 dot and three molecules of H2O and plus gibbsite plus diaspore. This is all. This is the second mineral present. it has the formula of Al2O3 and one molecule of H2O. So the percentage of these two minerals is the 65%, means 65.4%. It means the alumina, it has 60, and it has the 85.4% alumina in it. Means this much alumina can be extracted from these minerals. So the impurities in the mineral will can be Fe2O3. So this is iron oxide, titanium oxide, and silicon oxide. And there are two types of aluminum refining process. First is the carbothermic reduction or electrolytic reduction. So the refining process is divided into two types: carbothermic and electrolytic. So in carbothermic, it requires the reduction of the these minerals and aluminum oxide at very high temperature, means up to, means because the Al2O3 present is very stable compound. At is its dissociation temperature is almost at 2000 degrees Celsius. So means this will require high power consumption and resources. So the carbothermic reduction is not used. And in the electrolytic reduction, we can extract the aluminum oxide easily using the different types of salts like cryolite. And so this whole process can be done at around 250 degrees Celsius. In general, temperature is around 220. So only at low this temperature we can easily extract the aluminum oxide from the ore. So this is carbothermic reduction is not used. Electrolytic reduction have two types of processes. First is the Bayes process. So in the Bayes process, we crush the alumina and the crush the ore and then classify it, and then by going through the different types of steps like settling, washing, filtration, and heat exchanger, then precipitation, and so from the precipitation, the Al2O3 is precipitated. So this Al2O3 hydrate is sent to the rotary kiln. So in this rotary kiln, the anhydrous means Al2O3 is obtained. So this Al2O3 is then next fed into the Hall-Héroult chamber. Means second process is Hall-Héroult reduction. So this in this process, the one anode or cathode is made of carbon and steel, and this alumina is fed into that with some this the salt. So that salt is the cryolite. Means its formula is 3NaF dot AlF3. So this is called the cryolite. So this salt is very helpful in extract reduction of this alumina Al2O3, and from by processing this into, so we will get the aluminum metal from it. So the reaction associated with this extraction process are of two type, means type 1 the 12 NaF first dissociate into sodium plus fluorine ions. So these ions will further react with the element further the other salt, means like 12 sodium plus 4 AlF3 gives 12 NaF plus 4 aluminium, and further the fluoride iron reacts with the alumina, gives 4 AlF3 plus oxygen, and this oxygen and carbon also react to form the carbon monoxide or CO2. And in the type 2 process, the other reaction happens between these NaF plus twice of Al2O3. It gives 4 AlF3 plus 6 Na2O. And this Na2O will dissociate into 12 sodium plus 6 oxygen. Then this sodium will react with AlF3, gives NaF plus aluminium. And this equation also, the oxygen and carbon will react to form carbon monoxide and carbon dioxide. Further, the aluminium obtained from this extraction process will refine further to remove other impurities like oxides or elemental impurities. So fluxing is done after extraction process. So what are the fluxing agents? This is the NaCl or KCl. So this remove the oxide inclusions. Uh, and after fluxing, means impurities are removed. Next, the degassing will be done to remove hydrogen gas. So by vacuum. So this degassing can be generally done by the generating vacuum or by gas purging. So what we use for gas purging? Uh, the argon gas. Argon gas is noble and non-reactive. So this argon purging is done. During the purging, bubbles form, and that bubble collects the hydrogen gas and removes it from the melt. And one more thing to remove the hydrogen is the degassing tablets are fed into the liquid aluminium. So the degassing tablets. So these are the C2Cl6. So these tablets also form a gas which collects the hydrogen and remove it from the melt. Then next is the filtration process. So this filtration process will further remove inclusion. Inclusions are generally the hydride, means oxides, carbides, nitrides, and solid impurities. So the filtration is done by using a porous refractory material. So the liquid aluminium is fed into this porous refractory material, and so this porous refractory material will catch the inclusions of solid impurities, and the uh, pure aluminium will come out from the process. So what are the filters we use here? First is the fiberglass, tabular alumina, and ceramic foam. So the aluminium obtained from this process can be further divided in the classification of its purity level. Means the commercial pure aluminium has the percentage of aluminium from 99.5 to 99.79% aluminium. And if the purity increases, means after commercially pure, the high purity aluminium comes. It has aluminium around 99.8 to 99.949%. After high purity, the super purity aluminium comes. So it has aluminium 99.95 to 99.9959%. Then extreme purity aluminium comes. It has the aluminium around 99.996 to 99.999%. And the ultra purity aluminium have aluminium greater than 99.99%. So these are the grades of the pure aluminium. Further, what are the so this is the first the pure aluminium. So if there are some impurities or elemental solutes are present, so that will form the aluminum alloy. So the aluminum alloy are also divided into two types, or the 8 series, depending on the major alloying element. So the aluminum alloys can be first divided into wrought or cast alloy. Wrought means the properties can be changed using a mechanical tre- treatment. And in the cast alloys, The properties of the aluminum alloy are changed using heat treatment. And the alloy designation can be further divided into 8 series. So first it comes the means what are the designation. So first is the 1 triple X series, then 2X series, 3, 4, 5, 6, 7, and 8. So the 1X series is generally the pure aluminum. The 2X series is it has the major alloying element copper. Next has the manganese. The 4000 series has major alloying element silicon. Fifth, 5000 series has magnesium. 6000 series has silicon and magnesium. 7000 series has 7X series has zinc, and 8000 series has lithium. So the 3, 4, and 5 series alloy are the non-heat treatable, means they are the rot, or non-heat treatable can be said. Non means no heat treatment can be applied to change their mechanical properties. And other means when this is the pure aluminum. So the 2000 series, 6000, 7000, and 8000 are the heat treatable. And this aluminum copper is also heat treatable. So in the casting process, these alloys are further classified into different nomenclature. Means for casting aluminum alloy, we use other designation. So in this comes the 1X, 2X. Seven X and 8X. So in the previous page, we denoted the general aluminum alloy from the first digit and the uh, four other digits. It means here other digits will come depending on the secondary alloying element. So here we use 3X, and here we use two digits only after the primary alloying element. So this denotes the casting alloy designation. So for the this alloy, this is the pure aluminum. This is the aluminum copper. This is aluminum silicon, magnesium. Also have some copper. Fourth is the aluminum silicon. Fifth is aluminum magnesium. Seventh is aluminum zinc. And eighth is the aluminum and tin. So these are the casting alloy designation. And here the other one form also comes, means 1 xx dot x or 3xx dot x. So here the other digits come, and for this x after this point, it the this x can also have two values, 0 or 1. So the dot 0 means it is casting form, and dot 1 means ingot. So both are represents the casting as an alloy. So this is the, and 3000 like 3007 thousand 7x series has, this has silicon magnesium, and this has zinc. So both have, so in this two aluminum alloys, the intermetallic form is Mg2Si, and here is aluminum, zinc, or some magnesium, and copper is also present. So both of these alloys are heat treatable in casting. So the silicon present in the this aluminum alloy has very important role in defining the properties. So first, silicon lowers the melting point of aluminum, and it's provide fluidity. So due to very good fluidity, the intricate or complex geometries can be formed in casting. Complex geometries in casting is possible. So, what are the application of this aluminum silicon addition uh, in the industry? So, first is the, and silicon also lead to graphitization. So, this graphitization increases volume, means it have volume expansion. So the volume expansion will compensate the solidification shrinkage during the casting process. So this is also good. So the it has application in engine or in automotives, wheels, and uh, so the aluminum alloy in the automotive. The main purpose of the aluminum alloy is the weight reduction. Weight reduction will provide the full efficiency of the automotive. So how the silicon modifies the this aluminum properties. So first we will understand the phase diagram of it. This is aluminum means temperature. temperature in degrees Celsius, and the weight percent of silicon. So aluminum melting point is 660, and silicon melting point is around 1400 degrees Celsius. So the if we draw a diagram, so it have this structure. So the this point is called the eutectic. Means, do you know about the eutectic reaction? Hello. What is the eutectic reaction? I cannot hear you.
Liquid to also better.
Means the liquid transform into two types of solids.
Solid, yes.
Hmm. So the concentration of silicon at this point is 12.6%, and this point is the maximum silicon solubility in the aluminum. Sorry, minimum. And maximum can be 12.6, but it after solidification, the aluminum only have this uh, so this is the 1.65%. So in the solidified aluminum, only 1.65% silicon remains in the solid solution, and the all silicon will extract out from in the uh, other form. So this point is in the eutectic form. So here the alpha aluminum plus silicon forms, and the silicon present in the structure in the solidified alloy is the in the flat form or needle shape. So here is the liquid plus silicon, and alpha aluminum plus liquid. So liquid. So below the there so based on the eutectic point, we can divide two types of alloy, means hypoeutectic and hypereutectic. So hypoeutectic have silicon percent less than 12.6, and the hypereutectic have silicon greater than 12.6%. So the as the silicon present as in the flat form or needle shape. So in mechanical performance of the alloy, the needle shape is not required because that will lead to stress concentration in the component and early failure. So we do not require this needle shape morphology of the silicon. So to modify this morphology, we add some modifier like strontium. So if we in the strontium addition is generally 0.02%, it is very low. So this much amount of the modifier will change the needle shape into the globular or spherical type of film. Means it reduces the stress concentration and sharpness of the flakes. So this will lead to fibrous microstructure. And other types of modifier can also be added like barium, sodium. So only a very small amount of the modifier are required to change the shape of means morphology of the silicon flake. So what are the properties of the aluminum silicon alloy? It has the good corrosion resistance, good weldability, and low density. So because of this good weldability, they can be used in welding rods. So these welding rods and wire is generally used to fill the cavities between the aircraft components of other aluminum alloys like aluminum, copper, aluminum, zinc, or so. And this also used in the repairing process. Means the repairing process from this aluminum silicon welding rods is very easy, and the uh, very durability is also good for the welding of this aluminum silicon alloy. So this is is up to the hypo. And if we talk about the hyper eutectic aluminum silicon, so in that the alpha aluminum plus a eutectic silicon present plus the primary silicon particles, because it has the higher silicon concentration in it, primary silicon particles. So here also the primary silicon particles have morphology of the means sharp morphology. So this also reduces ductility. The hypereutectic aluminum silicon alloy, the most famous has the aluminum alloy 319. So the composition of this alloy is aluminum, 17% silicon, then 4.5% copper, and 0.5 magnesium. So the this alloy have high hardness. Yeah, so the hypoeutectic aluminum alloy, the most used aluminum alloy is 4043 alloy, hypoeutectic. It has 5% silicon, and in hypoeutectic this alloy has 17% silicon. So it has very high hardness, high wear, and tear resistance. So the application is in the pistons, and air condition compressor.
What compressor, ma'am?
Air conditioning compressor. It has
Okay.
application. So the means what are the mechanism? This silicon modify the aluminum means what are the mechanism of the means which governs the aluminum silicon properties. So if we talk about the growth of silicon particles, means how the silicon plaques form. So generally silicon have tetrahedral structure like this type. So this is the silicon tetrahedra. Means it shares the. So the valency is of this silicon. It completes like this structure, and for growth of the silicon plaque, two tetrahedra we require. I will write it here. So for the growth of silicon plaque, uh, two tetrahedras of silicon are required. Means it forms like this structure. And the bottom, the second, like this. So for in this growth generally happens by the twin plane retrent edge. Means in this type. Twin plane generally forms like this. So this direction is 112 or 2 bar, and this plane is 111. So the tetrahedra will arrange in this in this form means 1, 2, and 3, making the twin plane, and the growth of crystal will go either in this direction or in this direction. So due to this this mechanism, the silicon flags form in needle shape. So to avoid this needle shape formation, the modification is done. Modification of aluminum silicon alloy. So the one theory comes in the impurity induced twinning theory. So according to the this theory, the certain elements or modifiers are added, like we studied, like barium, sodium, or strontium are added. So these modifiers inhibit the growth of the silicon flags along the this 112 direction. So by the restricting the growth, uh, so this restrict the growth of the needle shape, and it also means the change the stacking sequence of the tetrahedrons, and form the branches in the during growth. And the newly added layers seek to grow around the absorbed impurity atoms. Means the these modifier atoms will attach on the this uh, on this silicon tetrahedra. So on by and as we attach on the this tetrahedra for or the flag formation. So due to that attachment, the stacking sequence change, and the newly added layer will adsorb on the impurity atoms, and the means and That's why they change the these means morphology of the silicon fats. So we will one go through the. Yeah, so now we'll study about some the manufacturing processes. Means what are the primary manufacturing processes of the aluminum alloys? So do you have any doubt up to this point, or can we can proceed further?
Proceed, ma'am.
Okay. So primary fabrication.
Okay, maybe one question, ma'am. What
Yes.
is actually what is actually the twinning theory? Like
Twinning
impurity induced
theory.
twinning theory you are saying.
Yes, means in impurity induced twinning theory. So means the growth is around this twinning plane. Na? So twinning plane is 111 and direction is in 11 by 2. So they sorry means they attach in the means the modifier atoms will attach here or in this direction, and as the silicon atoms will come, so the silicon atoms will have to absorb on these modifier atoms, so the flag formation will means break, means the sequence will break, and that's why the needle shape will not form.
Okay, okay, ma'am.
So the primary fabrication process, first comes the casting process, or the means after the liquid melt formation, the these that liquid aluminum or aluminum alloys are casted. So the most widely casting process is the direct chill process. So in direct chill process, the aluminum liquid is directly fed into water cooled mold. So what the use of this water cooled mold is, means it avoid the segregation of the alloying element, means what happens due to segregation means the microstructure will not be uniform, so and the mechanical properties will degrade. So by providing this water cooled mold, the segregation will not happen and the solidification will be uniform. So the water cooled mold can be of any required shape. So the this main advantage is uh, it eliminates segregation. Segregation that occurs in high strength alloys. Next is the rolling process. So in rolling, hot or cold rolling can be done. So the aluminum foil, this rolling can be done in foil, sheet, or plate form. So the thickness of this foil is means less than 0.15 mm. Sheet have the thickness around 0.15 to 6.3 mm, and the plate thickness is greater than 6.3 mm. Next process is the uh, extrusion. In extrusion also, hot and cold extrusion can be done. I mean, in rolling we form the flat uh, flat sheets of oil, and in extrusion we reduce the cross section of any ingot or billet, in cylindrical or rectangle type. So the cross section will reduce in extrusion process, or if we can give other shapes also. Next is the forging. So in forging, we use a die to form different shapes according to the application. Then other processes comes like deep drawing. So deep drawing are used to form wires or tubes of the aluminum alloy. Deep drawing, stamping, punching, drilling, or tapping. So these are the primary fabrication processes. And the other, so the aluminum alloys are also used in welding, so or in joining processes, means joining and fastening. So in joining process, the welding comes. In welding, there are types of, means tungsten inert gas welding, metal inert gas welding, thermite welding, and gas welding are generally used for the aluminum alloys. Means tungsten inert gas melting, thermite welding, or gas welding are used for the aluminum alloys. Next is the adhesive bonding can be done, and riveting or bolting. So these are the joining processes. Next, surface treatment of aluminum alloy can be of two types. Means one is the anodizing, means the one another metal is coated on the aluminum alloy to prevent the uh, uh, means to increase its hardness, wear resistance, tear resistance, or to increase the corrosion also. Next is the powder coating, and fourth, the powder metallurgy process are used to form the components, means near net shape components can be made, or the complex using the powder foam. Uh, Next is the additive manufacturing, means which are generally used in recent days. So the aluminum alloys can be used to form by additive manufacturing in two types, like wire arc additive manufacturing. This is known as WAM, or laser directed energy deposition. So the one more process is there additive manufacturing and that is LPPF, mean laser powder bed fusion. But the aluminum alloys has very high reflectivity to laser, so the means the process efficiency will not be uh, uh, good, and very process means the efficiency will be low for this laser manufacturing. So the wire arc additive manufacturing, which is a modification or means the commercialization of this welding process is very useful for the additive manufacturing of the aluminum alloys. Means the VAM is generally the wire and arc. So the wire is of aluminum alloy, and arc we can use any of type, like in inert gas. So according to the arc or heat source, this also VAM is further classified into means gas metal arc welding, tungsten gas tungsten arc welding, plasma welding, plasma arc welding, and the cold metal transfer (CMT). So these all four processes are very trendy in these days. Means generally the aluminum alloys are aluminum alloy component are generally manufactured by these processes in recent days. So this is all for today, and we will go through some questions based on the today's topic. So can you see these questions?
Yes, ma'am.
Okay. So first question is that I will increase this one. So aluminum and its alloys are most widely used in the following application. So which option is correct?
Seems like all actually.
No.
First two are correct. At least.
Yes. Electrical conductor and packaging. And the next question is the which of the following pair of impurities is responsible to reduction in tensile properties by forming brittle intermetallic compounds with aluminium?
And silicon.
Yes. The next is the impurities that increases the resistivity of aluminium are
Sodium and Sodium is not different.
no sodium. Need to answer.
Sodium is metal. Okay. Titanium, chromium, manganese, and vanadium. Okay. So titanium and chromium.
Yeah, titanium and chromium is right. Then next question is, purity level of commercially pure aluminum is
Fourth one, 99.5 to
99.5 to
99.79.
99.79.
Yeah. And the next question is, which of the following gas medium is usually preferred for degassing through gas purging to eliminate hydrogen from aluminum melts? Sorry.
Argon, yes.
Yeah. Next question is, which of the following processes involved in extraction process of aluminum?
Mm, it's electrolysis production.
Yes.
And the boxes being testing also. No?
Hmm.
They process.
Bauxite mining, crushing, then electrolytic reduction. Next question is, which of the following methods are used to remove gas impurities from aluminum?
Not just purging is correct. Degassing charges also is correct.
Yes. Inert gas purging and degassing tablets. Next question is, what is the main ingredient present in tablets used for degassing?
C2C.
T2CLC.
Next question is, by Sievert law, dissolved gas impurity concentration is.
But this we have not learned today.
Oh, means I skipped that point. So Sievert's law says the means how much concentration of the gas is dissolved in the metal. So this is given as the means concentration of the that gas is equal to square root of K Pg. So Pg is the pressure of the gas.
Write it even the square root of partial pressure of gas.
So the fourth option is correct. And next question is, what is the purity level of grade 1145 aluminum?
99.45.
Yes. Means the last two digit defines the purity level of this aluminum after 99.5. Yeah, so this is all. Do you have any doubt?
No,
Gabriel?
Yes, ma'am.
So can we end the session?
yes, ma'am. Thank you, ma'am.
Okay, thank you.
So your session will be every Tuesday?
Yeah, I will give. Yeah, this session will be every Tuesday, 6 to 8 p.m.
Okay, ma'am.
Week 2 session may be
Thank you.
next
Thank you, ma'am.
Thank you. Gabriel, are you asking something?
week 2 session, question answer session may be next week or another third week only, ma'am.
This is only this is the question answer session. You can ask in the
First
this
week or both first and second week.
first week, second week. This class will be every Tuesday, 6 to 8 p.m. So if you have any doubt, you can ask now or in
Okay.
further lectures also.
Okay.
Means, have you done the lecture by Professor Ranjit Gauri?
Yes, ma'am.
Okay.
Week 1 is fully completed.